Hello and welcome to another edition of Anglo-Irish Astro Geeks. To paraphrase Mr. Noel Edmonds, we have a full house tonight, so it's going to be a great show. I'm looking forward to this. I'll even pull up the show notes as well in a few seconds, and we'll get started. So anyway, without any further ado, my name is Nick Evetts.
I'm Antonin from Astronomy Ireland.
And I'm Neil Norman.
And would our guests this month like to introduce themselves too, please?
My name is Susan McKeon and I'm from Ireland.
I'm Helena Murphy and I'm from London.
Welcome to the show, ladies.
Thank you.
Generally, anything goes, really, I suppose. We have, if you heard the show before, you know we got a wicked sense of humour here. So, yeah, anyway, so it's been a great few weeks in astronomy. I'm actually imaging domes remotely. I'm going after the Valentine Dome, which is on the shores of, or rather the straits of Mare Serenitatis. It's volcanic in nature, so yes, I'm having fun with that. I think I've got it, but I really need to sit down with my virtual atlas and get started.
Did you have a look at Uranus the other night next to Mars?
No, didn't bother. No, it's too cold.
Too cold and snowing. We don't go outside when it's wet and cold, do we?
Well, I had patchy skies, but this couldn't be bothered.
Yeah, we had snow.
I had snow too.
Yeah, been chilly. But we digress.
We're digressing, yes.
Let's talk astronomy.
Yes, let's talk some astronomy. Right, so, where's my show note? Oh, here we go. Press the button. So it's been a busy week, as we've just hinted at. Well, tell you what, let's let Anne do what to see in the sky first. How about that?
Oh,
yes.
Well, there's not many planets visible this month now. All the kind of, spectacular ones are hiding at the moment. They've had their day and they're gone below the horizon, or they're too near to the sun. So apart from Mars and a very faint Uranus, there's not much, planet-wise. But there's plenty of deep sky objects to focus on, such as Andromeda, which is our nearest neighbouring galaxy, of course. And there's Orion, the Orion Nebula, M42, the Beehive Cluster, the Pleiades, and there's always the Moon. So even if there's no planets, apart from, as I said, Mars, which is moving away a little. So the next really interesting thing is February the 17th, which is Uranus is going to be 3 degrees from a 32% moon. So that should be easy to find then. It's so close to the moon. The following day, February the 18th, Mars will be 4.1 degrees above a 42% moon. Next day, the 19th of February, the moon will be between Pleiades and Hyades. So these are all interesting things, and it makes everything easy to find. And then finally, I just went up to February the 20th because she will be back by then probably. Aldebaran, 5 degrees from a 60% moon. So they're all easy. It makes, using the moon as your guide, it's easy to find everything that way.
Absolutely.
Yeah. I have to admit, I was shocked this week because The Guardian has now got a Star Watch section in the paper.
Really?
Yeah.
Who writes it?
I know I posted it on my Facebook. And of course, now it's being elusive. Because I've got so much stuff on there at the minute. I do know that they were talking about the winter hexagon.
Oh, do elaborate.
Well, basically, I've got to find I really need the article to do this, but because the moon is in the centre of the winter hexagon at the moment.
Mm-hmm.
And I really wasn't expecting to see it in a mainstream newspaper. I know the Telegraph used to do that really wonderful star map.
Yeah.
But that's gone. It's no longer available, I don't think. I've seen a few copies for sale on eBay, and that's about it.
Oh, maybe one of the Sky at Night team are doing it because they're off for 3 months, aren't they?
Yes, that's going to be hard. That's going to be very hard. No Sky at Night until April.
Yeah. 3 months of nothing. Oh. Why did they do that? I think it used to be Brian Cox and Dara used to do their bit, didn't they? But they don't even do that now because it went to Australia, didn't it?
Because they've got some Essex girl doing a show about conspiracy theory, part 2.
Oh, stop.
He's from Gogglebox, and I know Dara Nuveen was very, very hungry himself that he didn't get the time nor the money for his show. So, yeah.
Yeah, not good, is it, when you lose the Sky at Night for that sort of thing? But hey ho.
Well, Well, I don't think we get that political apart from having a go at Mr. Musk over his Starlink satellites, which have now been approved for use in the UK, believe it or not.
Don't get me started on that.
Oh, okay, here we go. Follow the moon to the winter hexagon. Okay, so the hexagon is made of Capella, Castor and Pollux,
Yeah.
Procyon, Sirius, Rigel,
yeah.
and Aldebaran.
Excellent.
So in the middle of that, of course, you have, near the centre, you have Betelgeuse, or Betelgeuse, as Patrick would say.
Mm-hmm.
And just above Betelgeuse is the moon.
Yeah. Or Beetlejuice, if you want to pronounce it wrong.
Neil, go wash your mouth out with soap and water.
I was just taking a mickey. I'm sorry.
Yeah.
Yeah, carry on.
But anyway, it's a fun asterism. It contains stars from 6 constellations, and it, of course, just to one side of Taurus and Aldebaran, just below Aries, is Mars.
Yes.
So, as I say, I've actually managed to quickly find it. So I'll put the chart into the link everything into the show notes. I'm sure the Guardian will be thrilled that we've actually mentioned them on the air and being nice to a newspaper for a change.
Absolutely.
So it's the view from London looking south at 2200 hours GMT on the 25th of January. Oh, that was last night. So the almost full moon would be cruising, as they put it, through the middle of the grouping. So you can actually, if you go anti-clockwise, you go from Capella to Castor and Pollux, to Procyon to Sirius until you reach Rigel again. So it's quite a large piece of sky that you're actually doing. Now, believe it or not, the constellations of Orion and Gemini, the twins, and Taurus, into perspective, you can also be seen from Sydney, Australia. Same view, but upside down, basically.
Upside down.
Yeah.
The wrong way up.
Well, the only thing with Orion, of course, in the southern skies is the fact it's always along on the equator for the sky, so it doesn't really rise that much. If you're in Australia.
Oh.
So we're lucky in some respects, being in the northern hemisphere. We actually get to see a lot more of it, and we can have much more fun with it.
Yes.
But it is probably one of the, I think, along with Cassiopeia, Ursa Major, Ursa Minor, it's probably one of the better known constellations in the sky.
They get Scorpius, nice and high up in their skies. I wish we could have that view, because it's a bit of a horizon hugger, isn't it?
Yeah. They've also got some real spectacles like Eta Carina and the Homunculus Nebula.
Yeah.
Everybody's been obviously going on about Betelgeuse going supernova and kicking it off for everybody.
Yeah.
But I think one of the really big sites would be Eta Carina going.
Blimey, yeah.
Because it's biding its time. It's one of those things.
What, that magnitude -10?
Yeah.
Daylight object?
Well, to be fair, Betelgeuse, if it did go, would probably be visible in daylight anyway. But really, if it happens, we want it to happen in our winter.
That's what they say.
Because then it's nice and high, and we get a really good ringside seat.
Of course, yeah. No, like it'd be in April when it's near the sun, and we can't see much of it.
Such as these things.
Such as I like.
But the other thing is, have you noticed, you can't get a telescope for love nor money at the minute?
Yeah, they're all sold out. There's been such a huge interest in astronomy over the last 12 months since the whole lockdowns began.
Yeah, good business to be in.
Yeah. Mind you, there's one site that's having a lot of trouble because since that certain event happened on the 24th of December.
The B word, is it?
Ooh.
Yes, the B word. Of course, a lot of his stuff is brought in from the EU, and now he's got to pay customs and excise on it. Well, the buyer has to pay customs and excise on it, pretty much.
Probably a mixture of Brexit and just the huge interest, the amount of people wanting to buy it. I mean, the amount of kids looking for telescopes from Santa we had so many queries.
Yeah.
And where can we get it? They're all sold out, So it's great interest.
But as I say, it's fun. I got my scope last year. The scope I wanted was the 20-inch Stargate go-to Dob. I couldn't get it because the manufacturer withdrew it, unfortunately. But I've got the 16-inch Explore Scientific ultra lightweight Dob. and I'm finally actually getting the chance to get some paving slabs down so that I can put it out in the garden. I've had it for nearly a year, but that's how, in some respects, that's how bad the weather's been. I've got it built under cover. Great rainy day product, building a Dob.
Yeah.
But, as I say, couldn't get it out. And then I had lots of fun with the remote focuser, and I finally got a remote focuser, and that's all set up. It's on the secondary. I was going to get everything outside and put back together, and I'm in business. But I won't be doing that much commentary work with it. It'll mostly be lunar, because I'm getting nudges from people I know in the States, etc., to join in with doing some lunar dome imaging. So.
Oh, you've got a Comet Leonard to look forward to. Surely you might turn up one evening over there. Have a gander.
Possibly, yes.
Yes. That one might be worth a look.
Very subtle, Neil. Very subtle.
Gregory Leonard, an old friend of mine, discovered it.
Yes, I know.
Yeah,
Same way I discovered Nakano's notes, because I thought you were talking about the other Saiichi.
I mentioned them last week on the other show. The man's a genius.
Yeah. I was referring to Saiichi Yoshida.
Ah, no, I was talking about Mr. Nakano. I did mention him by name. He is an absolute mathematical genius.
Oh, absolutely.
He finds all these lost comets and he knows where everything is.
But anyway, now we actually have two guests on the show.
Mm-hmm.
So, ladies, feel free to jump in.
Would love to, but I didn't want to be interrupting at the same time.
Don't worry, we interrupt each other.
But speaking back to trying to get anything to do with telescopes, I'm very, armchair, just kind of really started and was getting astronomy binoculars from a website, trying to get them in time for the conjunction. And I eventually got them the other day, and I ordered them in November. And I just kept getting told that they were meant to be with 7 days. And I do think there's been a huge backlog. And I think anybody in my position that's just an armchair, lover of this kind of hobby are having a hard time getting their hands on stuff. And I don't know if it's just to do with the B word or anything else. I think it's a lot of it's demand and everything else, because people are stuck at home. And
I think it's more the C word. Definitely the C word, I think.
Well, Susan, our astronomy club has doubled its membership since lockdown. So you can imagine all those people coming along saying, oh, I must get a telescope, I must get binoculars, all going to shops that expected to sell half that amount. So, yeah.
Absolutely.
So we're lucky to get them. And the binoculars are fantastic. Have you got a tripod as well?
No, I just have the binoculars, and I only got them the other day, and I'm delighted with them, but I would have loved them to have them in time for the conjunction, which was my excuse to get them in the first place. But sure, that's what eyes are for.
Yes.
I was going to say the next conjunction is only about another 700 odd years away.
Yeah, I'd even go for a half conjunction. I don't think it's going to be the same thing at all. But I'm definitely, I'm up for that if it ever happens,
Well, 700 years, we can all hope.
My brother has an amazing telescope. I don't know if you know John McKeon. He discovered the explosion in 2016 or 2017 on Jupiter.
Oh, is he your brother? He gave us a talk about it at the time.
That's my younger brother. And I mean, in fairness, he did say something about bringing his telescope up, but it's the amount of work to be done. His one is, it's quite out there. And, obviously then we've locked down everything else. So
yeah. That was amazing. He spotted an explosion on Jupiter. Something hitting it I don't know what it was. Was it an asteroid?
Asteroid, yeah. And it was I was on St. Patrick's night, which is a big deal here in Ireland, obviously. And he just turned out to be the only one that got it, So
and it was confirmed by somebody in Germany, so it was a definite thing. Yeah, and it was really exciting.
You know about these things, don't you, Nick?
Well, yes, Shoemaker Levy 9 springs to mind straight away. And of course, Anthony Weasley came along just after Shoemaker Levy 9.
Yeah.
And he had an impactor on Jupiter, and Chris Goad was the same.
Right.
I think Chris actually confirmed Anthony's detection, and then Chris got one of his own. So it is a regular thing, but the important thing is they're very important to catch.
Yeah.
Because we are, every time that we have one of these, it teaches us so much more about the inner solar system and the area around Jupiter and Saturn. I've made the comment a number of times that Jupiter is sometimes very benign. It will capture a comet, or it will capture an asteroid, and it will hoover it all up, so to speak, and take the damage. Either that, or it will actually turn around and kick a comet or a piece of space rock into the inner solar system, which makes it fun for us. So the thing was, though, it was Jim Scotty was saying, and he did a very nice painting of it, of a chain of craters across the surface of Callisto. Now, this crater chain preceded Shoemaker Levy 9. So, and everybody's been wondering, because we've seen something similar on the moon. So anyway, basically, they'd always wondered what caused that unique placement of cratering. And when Shoemaker Levy 9 splintered and started to pile into the Jovian atmosphere, it was like a huge light bulb going on. Like, hey, isn't this like the line of craters on Callisto?
In Callisto, yeah.
So it was suddenly, so this has obviously happened before. Instead of Jupiter catching them, Callisto was in the way and took the impact. We've seen it on the moon, and it's theorized that there may be a crater chain that's similar here on the Earth. But because we've got such an active geology and hydrology, it's kind of erased, geologically speaking, very, very quick.
Yeah.
But now we know what's causing it, so to speak. It's become... it kind of helped kickstart NEO-Watch, NEO-Shield, and Space-Watch really into high-level drive, because it suddenly made it very important to be aware and be looking for these objects.
Yeah.
But binoculars, going back to binoculars. Binoculars are brilliant because you can actually use them. You can get a very good laminated field map of the moon from Sky and Telescope. It's one I use at the telescope. It's also one I use when I'm trying to identify craters on a photograph. There's also something, if you've got a laptop or a computer, called Virtual Moon Atlas. That too is brilliant because it shows you the terminator. So it just follows the clock on your computer, and it will show you where the terminator is, and then you can literally learn your way around the moon and the mare, and it gives you a chance to recognize and be able to say, well, last night I was looking at, for instance, Hadley Rukl. Hadley Rukl on a good telescope is visible. You can look at the Montes Alpens, the Apennine moons on the Alpine mountains on the moon. Gosh, I'm getting excited. I'm getting my words wrong.
Be steady.
Yeah. But with that, you can start learning your way around the moon, and every time you go back to that particular moon at that time of the month, it will be different. Sometimes the sun angle will be such that you will see highlighted stuff you couldn't see previously. It's all down to the angle of the illumination from the sun and what you see and how you see it. There's guys out there who specialize in sketching craters.
Yes.
And that's all they do. And they have a group of craters, and at every opportunity, they're out there looking at this crater under different illuminations. So if you've got binoculars, put them on a tripod, because I've got 20 by 80s, and they're heavy.
Yeah, very.
Yes. So that way you also got a little bit more stability, and then you can start learning your way around the moon. And you can also use 20 by 8, really good astronomical binoculars. I would say if there's a comet that's at least third or fourth magnitude, you've got a very good chance if you know your way around the sky. So again, you've got a chance to learn your way around the constellations.
Yeah.
And then you can find some of the more brighter comets, even the so-called naked eye comets, unless they're in a minus magnitude, then you still need binoculars to see them. I know for a fact that's what you've done, Neil, last year.
All the time, yeah. I only use 20 by 80s for comet hunting now and observing because I find them easy to use and, taking out the 4-inch telescope. So I just throw the 20 by 80s up there on the tripod and, you can find some nice comets up there.
Yep.
And Messier objects too look really nice.
Venus is good in binoculars. Be careful about the sun.
Yeah.
And the planets.
20 by 80s, you'll get Saturn's rings, you'll get
Galilean system.
Yeah, you'll get the banding on Jupiter. If you've got keen eyesight, you'll see the banding. Venus, you'll see the phases. I mean, Mars, you can never see anything with unless you've got a big telescope, no matter how close it is. I mean, I just get so frustrated. I've got a 4-inch scope, and because I live in a bit of a suburban area, so I can't really get the big guns out because it's like pollution. And so, Mars has always been a disappointment, even when it's at its best, for me personally. So I just watch what Damien Peach sends in, when he throws out the pictures like he's in a spacecraft, 1,000 feet above the, atmosphere of Mars or something. The binoculars are just as good as the telescope. I mean, I know Patrick Moore used to say the same thing, and especially for the moon, 100%.
Start with binoculars, always.
Did you see Uranus below Mars last Wednesday, I think it was? You could with binoculars.
Yeah.
It was just like a little dot. But I saw it.
That's right. That's right. Yeah.
Just with
That's a
binoculars
good thing.
and handheld. Now, if you hold the very ends away from the part away from your eyes, you get a little bit more steadiness. It doesn't wobble as much. But you really need the tripod, yeah.
Yeah, for 20 by 80s, definitely way too heavy.
Next thing, I think, what is your opinion on Starlink?
I'm not allowed to.
Yes, Neil.
I'm not allowed to comment on that one. I'm banned. I have to ask our guests.
Yes.
Helena. Ask Helena.
I'm definitely not a fan, I have to confess. I think one of the things that I've really become passionate about, actually, in just like being an amateur astronomer, is the dark skies and preserving them. So I'm not a fan at all of the starlings, I have to confess. First of all, it can be a lot of fun, it encourages you to look up and stuff like that. But then when I started to really understand some of the, ramifications of them and the damage, the damages it causes and stuff, especially for people who like astrophotography and stuff, I can imagine it's quite challenging for them.
It has been. I will admit to that. What's your thoughts, Susan?
Well, I say armchair myself, but yeah, I'm not really a fan myself. I think they're far. I can see them like they're far too reflective. They're talking 12,000. I mean, it's a lot. I think there should be more thought put into it. I know Elon Musk has a huge brain, but I mean, I still think maybe our own planet, think about it a little bit first before we just start and put everything around it. There's enough up there already anyway.
Yeah, and he's not the only person doing it.
The plan is 42,000 of them. So
42,000, right? Yeah. Yeah.
Could you imagine, like, I don't know, even putting up a rocket through, the space station, if one of them hits it? I don't know what, that apart from obviously what we just said about the, what you said, Helena, about the, ruining the views for the amateurs and the professionals alike. But it's already now being tried out in the UK as a broadband provider.
Yes.
So, and then the people who are getting it in rural areas are delighted with it. So that's their side of it. But I don't think any astronomers are happy.
I know America now, they're literally getting rid of cable TV with this with coming online. Like, I mean, the cable TV companies are going to go off, and it'll all be Starlink, which I can see that as a good for people are in rural areas that need it. But at what cost is just my thought.
Yeah.
Well, the thing is, what got me was he was advertising this as being a extremely cheap way for Africa in particular to get on broadband.
Yeah.
But it's 439 quid for the kit.
Yes.
And then it's an £89 subscription
Yes.
for 150 megabits per second. How can Africa? I'm not being funny or nasty about this, but how can anybody in Africa really afford to use Starlink?
I don't think they can, but I did read something today that they are definitely going to be getting some kind of grants put in around the rural parts of America. I have no idea how that would work for Africa. I presume he's probably pushing it on that it would be good for the community.
Mm.
But hey, that's my opinion.
I'm not allowed to say anything, so I'll sit now.
There's no regulation. Like, it seems like Elon Musk just applies for a license to launch them from the States, and there doesn't seem to be any international regulation about which we need. We do need something more positive, more structured.
More worldwide.
The only
it's done now though.
Yeah.
What he did was he had an FCC license. The FCC gave him a license for his internet service. But the only things that are being protected are American radio astronomers. Everybody else, tough. Once you're outside the US and it's operating, nothing can be done about it. Legally, anyway.
No comment.
That's interesting.
Apparently, they're supposed to do an environmental impact survey, and the FCC didn't do it.
Well,
so that's what I understand. I probably just lost my US amateur radio license, by the way, for saying that.
I nearly got sued on the first show, so I can't comment. Carry on.
You're supposed to try to have less reflective surfaces, but that still doesn't deal with the space debris problem.
No.
To the space debris problem, like, does it?
Also, the space reflective surface they're talking about is obviously going to have to be some kind of paint. How the hell are they going to test it to see if it's going to live up there over in the environment near the sun? I mean, that would be a complete trial and error thing.
It is.
Is it even going to work?
It is because basically the first coating they used was a total disaster. It didn't work properly. Now they're saying that the basically the next one is supposed to be the bee's knees. They're supposed to do it. We're still getting flares. In fact, I suppose we all remember the iridium flares that everybody used to talk about in the press, and everybody would pile out their house to see a 3-second spark of light suddenly appear from a racing satellite.
I think Mary actually tried to get the whole lot, didn't she? Mary McIntyre.
Yeah.
I used to love those when I used to get -8, -8. Oh, wonderful. But these Elon Musk things, no comment.
I'm happy for him to work to go back going to Mars. That's fine. I can live with that. I can live with the fact he's making making low Earth orbit a much better proposition. That's fine, because high Earth orbit and beyond is the purview of NASA. That is apparently part of the license.
Yeah.
He's going to be allowed to go to Mars because it suits the powers that be, purely because it means there's more equipment they can use, and if there's an emergency, I suppose, it means they have a better chance of evacuating people, I suppose. In fact, saying that, I was watching the public lecture from the Royal Astronomical Society today. It was all about going to Mars.
Oh yeah.
And they missed out the 1958 study Wernher von Braun did, called Project Mars. It's available as a PDF, and I can give you all the link, and I will put the link into the show and to the public lecture from RAS. Having said that, Neil, I've just joined RAS, by the way.
Oh, congratulations! You're a fellow.
You're a fellow now, are you?
No, not yet. No. I was. Somebody whispered in my ear. Since they know this is something I'm going after, is join friends first.
Oh.
And that way you've got your foot in the door.
So you're not a fellow?
No, I'm not an FRAS yet.
Oh, you're still below me. Oh, no.
Yeah, not for much longer, Neil.
Got to get an asteroid and beat me, mate.
Tell you what, I'll get a comet. That would trounce your asteroid.
then I'll find another moon of Uranus. Then fine, I'll get my binoculars out.
And then your mum vouch the 2 years for arguing, and that'll be the end of that.
As I say, we all have a good laugh on this show.
I can get you an asteroid if you want an asteroid. Just
Yeah, fine, Neil. Get
DM me.
me an asteroid then, mate. I like that.
I'll have a word with, let's name drop Richard Kowalski.
Yeah. Jim Scotty.
Jim Scotty, name dropping. Yeah, no problem.
I think this is the thing.
Anybody else you want name drop?
David Levy.
Oh, yes, I know him.
So do I.
And actually, Fred Hayes, I'm in contact with him on Facebook. He was on Apollo 13. Your move?
Let me think.
Your
Rick
move?
Hill.
Who? Oh, Rick. Oh, he's discovered 13 comets. Yes, okay. But my man was on Apollo 13. No, he wasn't on. He wasn't on Apollo 13.
No, but he actually mentioned us by name, Neil.
Oh yeah, true. Actually, he did. Yeah.
He won't be chuffed. He won't be happy you forgot.
No, he won't. Will he? No, I'm sure he doesn't listen to this show. He's more of a comet.
Oh dear.
He won't be listening. Although that's still a good podcast. Sorry, Anne, we're talking crap, rubbish.
Yeah, no, I was going to say, I just found out yesterday that there's an asteroid called Pink Floyd. You probably
Wow.
Yeah.
I didn't know that, but it's quite near at the moment. It's kind of out beyond Mars at the moment. It is always out beyond Mars, but it's kind of nearby at the moment, like yesterday.
I have to say, it is ahead into the dark side of the moon. I mean, I had to say that. Sorry.
Yeah. I told my family about it, and they all mentioned the dark side of the moon.
Yeah. That's a favourite one, I think, with most lunar observers. There's no such thing as the dark side of the moon. It's a Pink Floyd album. It's always the far side. And then it will be followed by Have a Drink, Old Girl.
Naming asteroids after rock groups from the 1970s. Chris Wyatt used to like Pink Floyd. A big shout out to Chris with his Ice on Sun Cream. Probably still on eBay. Probably still on eBay there in Australia. Good man, well done. I think he actually told me the other day he bathed kangaroos and wombats in it. Apparently.
Sounds very Australian, all right.
404.
What?
Steve Bezos wants to get in on the satellite internet business.
Oh.
Boeing is trying to get in on it.
Well, they can't fly their airplanes now, can they?
They've all got huge constellations they want to put up.
All their bleeding airplanes are grounded, lockdown, you see, so they've got to do something else.
Oh, dear.
One day I'm going to slip up really bad. The day's coming. We have to ask Helena about her Facebook group.
Yes.
Astronomy in Pyjamas, which I'm a member of.
Yeah, that's name.
Yeah. Do explain about that. It's got some great people in it. I'm in it, for example.
Oh, it's a great little group. I started it in lockdown, actually, because what it was on my normal Facebook page, like a couple of you have mentioned, people started to take a lot more interest in what was going on in the skies during lockdown. And it just started a little bit of fun of me on my normal page, just posting some stuff for things to look out for and, what to look up in the sky and tracing out some constellations and stuff. And so I just started a little group. And the idea was it was just literally 10 friends I brought along on my Facebook page because I thought I must be driving everybody else mad with my constant updates about constellations and, Jupiter. So I just started this little page and brought 10 people along. And then what had happened, some of the people in my community live nearby and they started to ask me stuff. So then they joined as well. And then the next thing we knew, people from different areas we never met started to come along, and it's just grew and grew. And it's great because it's a mixture of people. We've got a couple of people who are, real professional astronomers. I suppose I better drop Neil's name in there as one of the ones who's knowledgeable.
Yes, I am. Yes, I have distinction and honours. Yes, thank you very much, Helen.
So we've got people like Neil there who are, really knowledgeable and stuff. And we've got people that's joined that, have never been interested in astronomy at all. And it's great. And, they've started to do photographing the moon, and one guy has bought himself a little telescope. It took him a while for it to arrive, but he's now interested in all the constellations. He's sending pictures of Orion and stuff, and it's just such a light, friendly little group. It's a lot of fun. It's got, it's only a small group, but the people are really friendly, and it's just people taking an interest in the night skies. But it gives me that little edge to drop in a little bit about light pollution and stuff like that again, and people start asking questions and what they can do to reduce the lighting in their area and stuff. So it's great. It's just a lot of fun.
We know how to get rid of light pollution, Helena, and Nick will tell you how to do it, but not from the famous person who told us to do it, Richard Kowalski. Go.
Very simple. You get a handheld laser and you point it at the sensor on the light, on the street light.
Yeah.
And it goes out.
Yeah, we never said that. Or you can use a catapult.
The safer method is to get one of those 1 million candle light torches. The big one with the D cells inside it. And you point.
Yeah, but you got to be careful.
You point it at the sensor.
Yeah, but if there's a police helicopter, you get nicked.
No. You're not pointing it that high in the sky.
They do. I saw it on television.
Or you could do. We have a chap who lives quite near me here, and he built his own observatory in the back garden, and it's in like a suburban garden. So what he did was he got the local council to turn down the lights around his area so he can do his viewing at night, and he actually discovered a couple of asteroids and a supernova from his back garden with the lights switched off by the council. So if you can get your council to switch off literally the ones around your garden.
No chance here.
His name is David Grannon. He's a great guy.
Mm.
I can vouch that the torch method is safe and legal, because when I did it, I was doing this in the States.
Oh, you did it?
I did the torch.
I actually
done it with a torch, yes. The million candle watt.
You're the man that they're up.
And actually, the officers came around and asked me what I was doing. I said, I'm turning off the street lamps without damaging them so I can look at the night sky.
Oh, yeah.
And I had binoculars out on a tripod at the time, and I let them have a look. And it was like, wow. And then one of the officers, very obligingly, who wasn't looking through the binoculars, used his 1 million candle watt torch to hit the other one whilst I hit the other one. And he says, oh, this is fun.
Really?
And they come back on later, do they?
Yeah, I think they actually go down for about 2 or 3 hours at a time.
Yeah, they would, wouldn't they? Yeah.
Oh, that's fantastic. I'm going to do that tonight.
Yeah. Yeah.
So you're basically filling the street lamps into sunlight to be quiet.
Yes.
But remember that Nick suggested it, not me. So when the police come around, blame him.
Yeah, no problem,
Yeah.
Nick. It'll be you.
He lives in,
Nick would be Nick. No problem.
Yeah, Nick, not Neil. It's definitely Nick. I'm not associated with him or anything. I don't know him.
Nobody knows what you look like, so we'll never find you.
Ah, well, I can fix that.
Helena, have you any advice about getting rid of light pollution or avoiding it?
Well, in our local council, actually, I did write to them, and they have changed the LED lighting in some of the parts where we live, because we've got a lot of wildlife by us. And we've got some people that do bat walks of an evening, and we kind of sold it to them and explaining the danger it was, the problems it was having with nightlife and stuff. So literally right around the back where we live, they put the lighting on in a certain area later, and are hopefully getting rid of some of the LED lighting, which is really, really good, because we was kind of explaining to them like the implications on, even like is it the circadian level and the hormones and stuff? And they actually took an interest and really listened. So it was really turned out to be quite a positive, conversation with them. It was good.
Good, that's fantastic.
I love hearing things like that. That's great.
The worst lights are the so-called security lights that people put up on their back doors.
Oh, right.
Because instead of pointing them down,
shoot.
No,
don't do that.
No, don't do that, please, because that'll get even more of a response. But seriously, the biggest problem is security lights, really, because you can be in your own garden, you can come out your back door and you haven't got them on, and your neighbour's one will come on.
Yes.
Because they're put up high up on the building, and the sensors literally are affected by your own garden. I walked down my garden towards the bottom, and the neighbour's one suddenly came on, which really did not make my night, because I was actually looking for a comet.
Oh.
I very rarely do visual observations because my eyes aren't up to it anymore. I wear trifocals, so I'm looking for a comet. I think it was a few years ago, and it was like really driving me nuts, because I had turned all the ones off where I live for a while,
Yeah.
so that I could get a nice dark area. Walked out onto the patio, and then suddenly the neighbour's light came on.
Yeah, they're shockingly bright as well. They really are. They're like you're literally caught in the headlights when they come on.
Mm.
And what's even worse is they don't really stop criminals, because criminals like them because they create areas of pools of darkness that they can actually lurk in. Most of the councils found that where they've turned the streetlights off, when they did that in Milton Keynes for quite a while, all the streetlights were put out because of the cost.
Yeah.
And crime didn't go up. In fact, people were actually able to see people who were on the paths or stuff without, even better than they would have done with the lights on.
Exactly. I mean, that's your night vision's gone then, isn't it? You get hit by one of those things, and boom, you can't see faint comets now, and you can't see faint Messier objects and things like that, because another 20-minute wait. You can't
see meteors either, meteor showers either.
Humans are bioluminescent, naturally we are, and we can't see it obviously because it's a very weak light. And our eyesight can't pick it up, but if it's completely dark, we will start picking up shapes, and not usually of each other. If you could imagine a proper dark place, we'd manage to see ourselves. We'd manage to see each other. There is a bioluminescence coming off us, but the light is so weak, it's not detectable by our eyesights. But our eyesights are used to so much light now, in comparison to what they would have been before we had it.
Yeah,
I think that's the nice thing about going into places like the Brecon Beacons, and I think there's what was that place David suggested I go to, Anne, in County Wicklow, was it? Wicklow Mountains?
Mayo, Dark Sky Reserve, or Kerry. There's also one up in Northern Ireland. Oh, God, I don't know the name of it. Can you remember the name, Susan? It's like a name like Davenport. No, tip of my tongue, gone. Can't remember. Anyway, it's just newly opened in the north of Ireland. Just opened, and then the whole lockdown happened. Mid-Ulster Council runs it, so it's Mid-Ulster is where it is. It's easy enough to find. They're fantastic places. They're so dark.
I think it was the Brecons. That was the first dark sky location I went. Oh. I think that's really where my real passion for astronomy grew. The first time actually seeing the Milky Way, it was the most beautiful sight I've ever seen, and I'm just privileged to be one of the small percentage that gets to see it with my naked eye. It really, I think for me, that's what really done it, because I'd never seen a dark sky before. And although I'd heard people talk about them, I'd never actually experienced it. And I can just remember that day like it was yesterday, the most beautiful sight ever. It really, I think once you've seen that, it does really change your whole understanding about it.
It's very hard to make out the constellations, because it's just as if somebody scattered loads of diamonds all over the sky in every little corner.
It is breathtaking, though. You do see something beautiful. It does. When you actually see something, you're like your breath goes, and that's it. You're just hooked.
It's at the foot of the Sperrin Mountains.
That's the one.
Devagar, closest I can get.
Darva. VAGH, yeah.
That's it. DAVAGH, yeah.
Yeah, I just couldn't remember.
The Big Moorstone, near the Big Moorstone Circles.
Oh.
Yeah.
So if you're listening to this in Northern Ireland, you actually have you're lucky to have a dark sky reserve right in your neighbourhood.
And you should also apologise for your bad pronunciation of their name.
Listen, I'm learning Korean, Cantonese, Japanese,
but not Irish. This is the problem.
No, Irish.
I know enough Welsh to save my life if I have to.
Okay, let's talk astronomy.
Yeah, let's get back to astronomy.
Comet Schwarzmann-Wachmann.
Schwarzmann-Wachmann, SW1.
I always mess it up.
Don't worry about it, Neil. Everybody else does too. I just call it SW1. London has a comet. It's called SW1. Anyway, so the European Space Agency has a new exoplanet watcher.
Oh.
Yep, and it's revealed a unique planetary system consisting of 6 exoplanets.
Mm-hmm.
5 of them are locked in a rare rhythmic dance as they orbit their central star.
Yeah.
but the sizes and masses don't follow an orderly pattern. And it's interesting, it's actually challenging the current theories of planet formation.
We get this though, don't we?
Yes.
They say, for example, how can hot Jupiters be so close? I mean, they've found hot Jupiters that that are actually bigger than Jupiter, that are closer to their stars than Mercury. I mean, how does that work without the atmospheres being blown away? Now I know they're pretty massive; they can hold on to their atmospheres, but if you're even closer to the star, you're going to get, it just doesn't. It's baffling, confounding.
The thing is, though, is the current theory on the evolution of the solar system. It placed the gas giants in the inner system, and most of the rocky planets in the outer system, because when they're and this is something that's coming from exoplanet observations from orbit, is the fact that they're finding so many gas giants close to the star than we're expecting.
Absolutely.
So the infant solar system may have been a completely different place. It may have had the gas giants closer in, but something disrupted the solar system, and it caused the rockier terrestrial-like planets, Mars, the Earth, and Venus, and Mercury, to come into the inner system, and the gas giants to go out into the colder outer system. Because basically, if they're formed in the outer solar system, how could they have had so much gas?
Well, yeah,
they would have had to have collected that gas in the inner system.
Yeah. I saw a program where they placed actually sort of like Jupiter would have been where Mars is now, and Saturn would have been roughly where Jupiter is now, and they were in the resonance as they were going round, and they were tidally locked, and they were sort of like tugging each other and pulling each other away whilst encountering the rocky planets and sucking them in through perturbations. So that's how it's sort of a tidally locking dance over millions of years. But it does make sense. Yeah, they would have to get most of the gas from the inner nebula. Yeah. So
one of the striking examples is a planetary system called TOI-178. It's about 200 light years away. It's in the constellation of Sculptor. Now, I'm hearing music.
Sorry, that's my bloody tally. I apologise. You know what?
That's all right. Oh dear.
Was it good?
Reality. Anyway, it doesn't make any difference. The telly, I had it paused, and I apologise to say I'm completely
That's okay. That's not a problem. It's just that the last time this happened was actually on a live show, and people in the chat room, I think it was an episode of the Event Horizon. I used to do that when I was in the States.
Oh wow.
Marty. Yeah.
Yeah, with Marty, and suddenly we could hear music.
Yeah.
And then we could hear another show underneath us. So it was oops. But it happens. Don't worry about it. Anyway, so Cheops, and I probably pronounced that wrong.
Probably.
My Egyptian is very terrible. I can just about order a beer in Cairo, and that's about it.
Go on, order it.
In beer in Fudlick.
Wow. Better than your Irish.
Yeah, better than the Irish. I think that's really rather good.
Anyway, so the astronomers were expecting this star to have at least 2 or more exoplanets. Now, when they looked at it using tests, and I think that was after they'd using the Transitory Exoplanet Survey satellite test, and of course, new even more precise observations were CEOPS, which is NASA's Characterizing Exoplanet Satellite. That was launched back in 2009.
Blimey.
So this star system has at least 6 planets, and it's a very unique layout. Adrien Lelou of the University of Geneva and University of Bern in Switzerland published their results about this in Astronomy and Astrophysics. One of the special characteristics is that, except for the one closest to the star, they all follow a rhythmic dance as they move in their orbits. As you said earlier, this is what they call orbital resonance.
Yeah.
It means that there are patterns that repeat themselves as the planets go round the star, and sometimes with planets aligning every few orbits.
Yeah.
There is actually, if you look in our solar system, there's a very similar renaissance there. I'm going to have a glass of wine in a minute. It's the orbits of 3 of Jupiter's moons. That's Io, Europa, and Ganymede. For every orbit of Europa, Ganymede completes 2 orbits, and Io completes 4. This is a 4-2-1 pattern.
Absolutely.
So what they're seeing in TOI 178 is that this is involving 5 patterns following an 18-9 to 6-4 to 3 pattern.
Mm-hmm.
Where the second planet, the first in the pattern, has 18 orbits.
Yep.
The third planet, the second in the pattern, completes 9, and so on.
Excellent stuff.
So we have something similar closer to home,
Mm-hmm.
which we can observe. And of course, initially there are only four of the planets in its resonance. But they figured by following the pattern, there had to be another planet there.
Excellent.
The fourth following the pattern, the fifth planet from the star. They predicted the trajectory very precisely, and they assumed it was in resonance with the other planets. And after additional observations, the platform confirmed that the missing planet did indeed exist in the predicted orbits. In some respects, this is history turning to itself here. We found most of the planets in the solar system beyond Saturn in similar ways. Mathematics pointed to there had to be something there that was perturbing all the other orbits. So we found another planet, and we found another planet, and the only joker in the pack really was Pluto, which is in my book still a planet.
Yeah.
Being so far out and having such a different orbit to the rest of everything, because it actually crosses inside the orbit of Neptune.
Absolutely. Yes.
So, of course, we knew there was something out there, mathematically proved Planet 9. Well, now they're talking about Planet 9 actually being either in the Oort cloud, and that could actually be halfway to Alpha Centauri.
Yeah.
They reckon there's something massive out there that's so dark we can't see it. It's got to be a gas giant, and it's perturbing the orbits of some of the Kuiper Belt objects.
Yeah, Sedna is a very strange object.
Yes.
Sedna should not have its aphelion that far out.
Mm.
In just bizarre angles to the solar system, the ecliptic plane. Something had to have put Sedna there. There's no doubt about it, no matter what anybody says, because you look at the diagram, Sedna should not be where it is.
Yeah.
Full stop.
Well, the other thing, of course, is a lot of people are using Schultz's star as being the perturber, but I don't think it is.
Oh.
I'm of the opinion that it's actually possibly a whole group of smaller objects, maybe.
Mm-hmm.
But having said that, the solar system extends so far to Alpha Centauri, it's not funny.
Mm.
Well, you've seen the graphic I found, because we talked about it in Comet Watch.
Yeah, I did, yeah.
And that just shows you how massive our solar system really is.
It's crazy.
When you take into consideration the Oort cloud.
Exactly. Don't forget, I mean, the Oort cloud, we must say, for those who are completely new to the astronomy thing, is hypothesized. We do not know the Oort cloud exists 100%, but we have to hypothesize it's there because of the way that the comets come in from all these crazy angles, like Leonard is now, for example. They come in from such strange, highly inclined orbits that something had to,
I think the thing is, though, the Oort cloud is mathematically provable. So you've got the Kuiper Belt.
Yeah, but we cannot see it. I mean,
but we can see its actions on the solar system.
Yeah.
On some of the trans-Neptunian objects that are out there.
Plenty of those. Yeah.
And of course, there's comets, Comet Borisov 1, which was the second interstellar object, and of course Oumuamua, which kind of, in a way, proves the Oort cloud in my books, anyway.
Yeah.
What do you think about the exoplanet thing, Susanna?
I think we need to open our minds a little, but I'm sure you don't want to hear this. Mm-hmm. That we can't be putting our what we know on that system. We only know what we know. Mm-hmm. We have no idea what way things work in any other system. We barely know what's going on in our own system. We still haven't even investigated the moons on Jupiter or Saturn or anywhere, the ones that may be life-giving, maybe life-holding. And I think sometimes we get bogged down too much in the science of what we think we know, that we're not open to the fact that maybe there's so much more. There's so much more that we don't and can't understand. So whatever way that exoplanet is working or moving around is probably not normal for it.
Yeah.
They probably think we're weirdos, you know?
Well, one of the things I've said it a lot of times. I think if there is life out there, this is a quarantine solar system. Human beings, we're a nasty, juvenile, vicious species, and we're not ready to if there is.
Yeah, not ready.
Yeah, and to be honest, the other question, of course, is have we missed it by several billion years, or are we several billion years too early?
They've been here before, you know, before we were around to even cop on what they were. Were they here before? We don't know. For our little minds to even think of the amount of area we'd have to cover to get to anywhere near what we think we can get near to, like maybe we're just, you know, it's not been that long. We're only here, what, 10,000 years probably. You know, we're not worth it, I reckon. It's just.
No.
Helena, what are your views on the exoplanet discoveries?
I've got to be honest, I don't know. It's not something that I've really got a lot of knowledge on that, to be honest with you. So, yeah, I'm probably best not to comment on that one.
Okay, so let's. What else have we got? Dark matter's in the news again, because what they're seeing is that a cosmic ray detector may have actually spotted nuggets of dark matter.
No. Well.
I think that's a story I actually shared in the messaging chat.
Yeah.
It is. That's the same one.
Basically, what's happened is a series of mysterious events have been recorded by Cosmic Ray Observatory a decade ago, and they're now thinking that it could actually be the signature of an unusual form of dark matter called axion quark nuggets. And this is according to Ariel Zhehiski of the University of British Columbia in Canada. These nuggets are actually hypothetical bundles of antiquarks, or quarks wrapped inside a layer of axions, which would only reveal their presence when passing through dense regions of the universe, such as stars and planets. So we know that the only way you can detect neutrons is actually in the very liquid you use for dry cleaning.
Yeah.
It's one of the best liquids we have for putting neutron detectors into. So what happens is a neutron comes through into the tank, it collides with an atom and creates an atom of chlorine. The detectors, what they're doing is they're actually detecting the presence of chlorine. So they're working out the number of neutrons being detected by the number of chlorine atoms, which are now suddenly appearing in the vat of the dry cleaning fluid.
Blimey.
The other thing, of course, is that the Pauli exclusion principle leaves open the possibility that a large enough number of such quarks could create dense, stable entities known as strangelets. Now, since more of the quarks would occupy low energy states than is the case in normal matter, because normal matter only has up and down quarks. I figured I'd be doing this story somehow.
Yes.
So, okay, thank you, Neil. Anyway, basically, by encasing these particles in a layer of axions, these were high. I'm having to make sure I give the background as well, because otherwise people are going to be diving on the internet.
Yeah.
And shutting down the internet, looking up axions. So axions are hypothetical particles postulated in the late 70s to ensure that neutrons could be described in the terms of the strong force without breaking charge parity symmetry, or CP symmetry. Later they became a candidate for dark matter. In the case of the axion quark nuggets, they would enclose dark matter made up of quarks rather than forming the dark matter themselves. The idea is that the universe should contain or would contain equal quantities of matter and antimatter at all times. Now, the problem is the universe doesn't, because matter predominates. Because when matter and antimatter meet, there is an explosion, basically, and a release of hard radiation. So, technically, in order for the universe to exist as we know it, there has to be a lesser amount of antimatter. So, they're saying early on in cosmic history, CP violating axions would have led to the creation of more nuggets containing antiquarks than those containing quarks. But then conversely, you had more quarks available for nuclear synthesis than there were antiquarks. So basically, if you've got more antiquarks, you can't have nuclear reactions, which is what powers a star.
Ooh. Yeah. Okay.
The net result, of course, is that we have a visible universe dominated by quark matter, while most of the mass inside nuggets, the dark matter, would consist of the antiquarks or antimatter. So they're saying that the density of the nuclear matter, those nuggets would have had a macroscopic masses, perhaps 10 grams, whilst measuring about 1,000th of a millimeter across. They would certainly interact extremely weakly with other matter, and in the rarefied environment of deep space, they'd be completely inert. But it's only in the presence of more dense matter, such as in the center of galaxies or in planetary atmospheres, you actually get to see them.
Okay.
Now, this brings into anomalous bursts. So, according to the author of the paper, the telescope array in Utah might have seen such interactions. The observatory, by an international collaboration, uses thousands of scintillation detectors spread around over 700 kilometers squared to detect the air showers produced when high-energy cosmic rays interact with nuclei in our atmosphere. However, there's still a small part of the data collected in the array between 2008 and 2013 that was anomalous. Now, the collaboration reported in 2017 that having observed what is described as 10 short bursts of detections that look very different to normal cosmic ray air showers, it calculated that there was less than 1 in 10,000 chance of those bursts involving the recording of at least 3 microsecond long shower events within a millisecond, and would be due to the random coincidence of individual air showers. What's more, all those events took place during thunderstorms. The bursts strongly correlated with lightning strikes both in both time and space. So it looks like we're actually going to get maybe an answer to does dark matter and dark energy really exist? Because if this is the case, that we can now detect dark matter, it may actually allow us to find out just what the real mass of the universe is.
Interesting.
So the detection is dependent on an atmosphere. So if you have an observatory, say, on the moon with a very thin exosphere, believe it or not, there is a slight atmosphere to the moon, but it's negligible. It's so little. It's so
Negligible. Yeah.
negligible. It doesn't exist. You need a really good atmospheric envelope to detect it. So yes, the moon is going to be great for optical astronomers and for radio astronomers. Radio observatories can go to the far side of the moon, so can optical astronomers. They're talking about making mirrors from liquid mercury, taking up entire craters for the mirror. Can you imagine a mirror hundreds of kilometers across in a crater?
Amazing.
And I think this is probably why we have to go back to the moon, because we have the ability to shield ourselves from all the incessant noise, radio noise, that we generate on the Earth. And out there is the chance of a pristine environment for radio astronomy. And of course, with the negligible exosphere, it means that the millimetric lengths that radio astronomers are using, from about the hydrogen line onwards, it's going to be so much easier for them that maybe, I think in the future, you're going to find all the major radio observatories will be on the far side of the moon.
Yeah, I think so.
So the other thing, of course, is that the European Space Agency is sending up even more satellites with a good function this time. These are EVSat and Cryosat, as well as the Copernicus Sentinel 1 and 2 missions. And they're all actually being tasked to climate change and seeing how the atmosphere is acting, and allows us to see and make a survey of global ice loss using satellite data. And of course, what they're beginning to find is that the ice is actually disappearing at a faster rate across the planet. They reckon about 28 trillion tons of ice were lost between 1994 and 2017, which is the equivalent of a sheet of ice 100 meters thick, covering the whole of the United Kingdom.
Cool. Blimey.
Makes you think, doesn't it?
There's a good graphic of a giant ice cube sort of covering New York to give you an idea of it. It's a really good graph. We should stick it on the end of this at the end. Have a look.
Mm. It shows you how strange things have got. For the fourth time in 50 years, there's been ice in the Sahara Desert. Ain Sephra sits about 3,280 feet, 1,000 meters above sea level, and it's surrounded by the Atlas Mountains near the Algerian-Moroccan border. Summer, you've got about 38 degrees Celsius. January, you might have a rare night where it drops to -3. But any snow and ice in the northern Sahara is unusual, but not unprecedented. So this is the fourth time in 42 years that this mountain has seen snow.
Wow.
With previous occurrences in 1979, 2016, and 2018. And they were much heavier in the past than they were in this week's. In 2018, northwestern Algeria saw up to 15 inches of snow. And in 2006, a blizzard dumped more than 3 feet, 1 meter in select regions. But again, this is putting science to use. This is putting satellites to use. Who would like to do the giant claw story?
Go on then.
Oh, okay. Since the first satellite was launched in 1957, we put thousands and thousands of objects into orbit, and there's about 3,000 active satellites, and we also have 900,000 pieces of space junk larger than 10 centimeters. And even if one little tiny piece of debris collided with a crewed spacecraft, or even if it hit a satellite, it could be catastrophic. So it's something you want to avoid. So a lot of agencies are looking at ways to clean up space. There's been all kinds, I'm sure you've seen all the different things, but the latest one is some kind of a claw that will, the problem is the speed that they're traveling at to try, and you can't just put a net. I've seen a net one as well. How do you catch them? I mean, the speed, But and a lot of them can remain in orbit for years afterwards. I was actually asking, we're going to put our own satellite up. Ireland is called AirSat-1. It's just a little CubeSat. It's 2 CubeSats stuck together, And one of the questions I asked them was, will this contribute when it's finished? Because it'll only last for some months. And I said, is that going to contribute to space debris? But they said, no, it will drop and burn up in the atmosphere. So we're not going to do any damage long term. And it will be doing some science. It's going to have a gamma ray detector. And it's testing out a thing called solar white and solar black, which is a special thermal coating for a spacecraft. And it's already on Solar Orbiter. Excuse me. But they're just testing out to see how it works in space, and they have, they're checking it out. So anyway, I'm digressing a little bit from the claw, but so the target of this mission is a VESPA, which is a VGAS secondary payload adapter, and it was left in a 400-mile high orbit since 2013 and helped launch a Vega rocket in 2013. And they chose this object because its orbit and composition are well understood. It's about the size of a small satellite. And the mission is going to be called Clear Space 1, and it could launch as soon as 2025. So the actual spacecraft is claw-shaped, and it's going to rendezvous with this piece of VESPA debris and lock into it with grapplers. And then it'll just drag it down through the atmosphere where the claw will burn up. Now, you'd obviously need loads of these devices, but this is just an initial test to see if it will work. It's just one of lots of ideas. But if it is viable, we just need to do something, because the more cluttered that space becomes, the more dangerous it is. And some scientists are even worrying about the chain reaction of space collision, which is known as the Kessler effect, which would mean that we could actually render space useless around the Earth for years or even decades just from all this space debris. So it's a good idea.
Definitely.
If you want to see a very good demonstration of the Kessler effect, watch The Beginning of Gravity.
Exactly.
With Sandra Bullock and I can't remember the actor's name. What's his name?
George Clooney.
Yes, thank you. So they say that the big thing is no one's ever bothered to worry about what we're going to do with all the dead satellites.
just me myself, as I, entered into this world over the years, I was beyond disgusted with when I realized how large and how much was out there. And then I read about the claw thing, and it did remind me of a bit of James Bond, and let's just go in and grab it, like Moonraker, is it when he goes up and he grabs stuff?
Mm-hmm.
But also I do see there is a good idea there, but maybe we need an awful lot of them, and we need an awful lot of them to get them into a low Earth orbit and see what happens. But I think more needs to be done, because I think we're already ruining the outside of the planet, never mind the inside as well.
Yeah.
One of the interesting things is, at the moment, the fate of the Hubble is to burn up and splash into the Pacific.
That's right.
There is a satellite graveyard, a space station graveyard in the middle of the Pacific Ocean at one of its deepest points.
Yeah.
So that is where the Hubble will eventually end up, if there's anything left of it after re-entry.
Yeah.
Kind of ironic, the Hubble actually was able to happen because the mirrors that were originally done for the Hubble came from a SpySat program.
That's right.
Wow.
And there was these two huge mirrors that they had, and they wanted a use for them. There was nothing they could use them for, really. They were originally designed to look back onto the Earth and be used for the powers who owned it to take photographs of military installations.
Yep.
See, the thing is, what people forget is we're so happy, we so love our mobile phones, our smartphones.
Yeah.
And they don't realise it is trickle down from the space program.
Was that from the MOD?
No, this was an American project.
They had the mirrors facing in certain ways as well.
Yeah, a lot of countries that use spy satellites either use optical or digital detectors. In fact, again, trickle down from the military programs is the charge coupled devices we use in astronomy most nights.
Yeah.
That's where it came from. The technology was originally designed for looking on seeing what your neighbour's up to with his army, and there was a civilian application, and it just took off.
Yeah.
It originally was the big observatories could afford it because of the cost to build charge coupled devices.
Yeah.
For astronomy, and with the technology getting better and better, it got smaller and smaller, and then the manufacturers like SBIG and stuff realized that there was a home market with the amateur astronomers. The thing is, people don't realize a lot of amateur astronomers, in fact most of us, have professional grade instruments, which is why we're seeing so many of the professional amateur collaborations on comets, on asteroids, on variable stars. The AAVSO has a program, and they send out messages to their members to observe certain stars months before the Hubble is turned into that piece of sky, because they want to know how to get exact timings on variable stars. They want to know how dim it gets and how bright it gets.
Yeah.
And amateur astronomers can do that. We have the knowledge, we have the instruments to do it. And of course, with with man going back to the moon and to live on the moon, one of the programs that is going on right at this moment, there is a lunar impactor program being run out of NASA. There's a huge number of amateur astronomers look at the moon every night. They image. They have timers that are superimposed on the video they're taking, and of course their GPS information. And that information, yes, I still see announcements that there's been another lunar impact detected. Most of the time it's during the waxing moon and sometimes during the waning moon, but not really at full moon.
Mm.
But it's a program that amateur astronomers can do and get involved with. Brian Kludnik, I think, is the guy who's running it. He wrote a very good book on it, and it's out there. Springer made it available under I think it's part of the Patrick Moore Library. But it shows you what we amateur astronomers can do. During the Rosetta mission, in the prelude to Rosetta, going to 67p, we, the amateur community, were observing it. We're doing that with 29p SW1 because we all want the SW1 to have its own space mission.
Yeah.
It is a reasonably pristine comet. It's an outburster. It's a Jupiter comet, family comet, which makes it even closer to us. It just trundles between Saturn and Jupiter on a regular basis. And we are getting very good at timing the outbursts, imaging them, doing photometry. And if you want to get involved in the 29p, all I will simply say is take luminance only images.
Yes.
Because I've actually taken images for the program. I sent Dr. Richard Miles a beautiful color image of 29p, and quite correctly says, "Now, Nick, I need the luminance only image, please."
Mhm.
So I was able to go back, pull it out of my collection, send him it.
So can you explain luminance only to us?
Okay, so you've got when you're taking an astronomical photograph, you're using a black and white, a monochrome camera. So you have 4 filters: luminance or clear, red, green, and blue. And you combine the filtered images to get a color picture.
Mm-hmm.
And that is actually how the Hubble Space Telescope works. The pictures are processed to bring out the color image. So now these days you can get single shot color CCDs for amateur astronomy. Most of the imaging is done with a processing program. I use Nina. Some people use PixInsight. I've used it. I had a trial license. It's a lovely program. My gosh, it's complicated. And you can get programs like GIMP and Deep Sky Stacker as well. So basically, you're taking 4 images and combining them to make one color image. So the luminance is the clear basically a black and white image.
Yeah.
Okay. So you know the like Zooniverse project, the kind of citizen science project where they just get ordinary people to have a look and watch out for asteroids. You must know all about this. They would only be looking at the black and white kind of spectrums. Yeah.
Yeah. Basically, it's a monochrome. It's the monochrome image, the luminance, and then you add images taken with different filters to build up a color picture.
Okay. Well explained.
You're looking at maybe 100 images over short durations with filters, all combined into one to get a color picture. I hope that makes sense.
Yeah, it does. Yeah.
You're doing it all the time. So when you're asked, okay, what image do you want? The researchers say, well, I might want a color image. I might want it with certain filters. You can also get hydrogen alpha filters, oxygen filters as well, which highlight various aspects of the image when they're used in sequence. So you're looking at basically taking a minimum of maybe 100 pictures over a very short period with different filters, and you combine all the different filters to get the final picture. So when you're looking at the coffee table book picture of the Crab Nebula, you're looking at a picture that was taken in maybe with 4, 5, 6, 7 or more filters.
Mm.
And of course, today, what NASA does, they now release a lot of their deep sky images in a total image, combining everything from X-rays to visible light and beyond. So you'll have a radio image, you'll have infrared, ultraviolet, X-ray.
Yeah.
To get a composite image that really shows what a nebula is like.
Yeah, I love looking at those.
Yeah.
A lot of the solar people would know that, wouldn't they? Because the solar stuff is always put up in different wavelengths of light, isn't it?
Yeah. Yeah. Basically, today, people like the European Southern Observatory and NASA, when they release an image, it is going to be a composite picture across the whole wavelength, from radio all the way through to visible light and beyond. And those pictures, I downloaded one, I think, it was a southern object. It was 72 megabytes. Most pictures, 12, 13 megabytes.
Yeah.
But after adding all the various wavelengths in, the smallest version of the picture was 72 megabytes.
Mhm.
The full everything in its glory was 1 gigabyte.
I mean,
This just shows you how much information, 1 gigabyte of
yeah.
information in that picture. It took 2 hours to download.
God.
Yeah,
And those are the ones you see on your computer desktops these days.
they're layered. Yeah.
Yeah.
I looked through a telescope to see Saturn. I was so disappointed because I was expecting a Hubble picture and there's just a little tiny thing with 2 arms on it.
Mm.
That's
now
it.
now I really appreciate because it's so far away. But the first time I was expecting something like you just described.
Yeah.
How about you, Helena?
I loved it. It was an unusual circumstance. It was a chance encounter. As my daughter was having an interview at secondary school, and her school has its own observatory. Someone asked me if I'd like to come along and have a look, and it was Jupiter and a couple of the moons I saw the first time. But yes, it's nothing like you'd expect. It is quite small and stuff, but I think it was just the whole experience of someone just off the cuff asking me to come along and have a look. And that was the very first time I'd looked through a telescope. I often wonder, had that guy never come over and said, do you want to have a look through a telescope? We've got an observatory at this school. It could have been a completely different journey. It was literally from there that I started to take an interest in the night skies and stuff. I didn't rush out and get a telescope or anything like that, but I just bought myself a little stargazing book and started to find my way around and joined like a little society and stuff like that and got to know other people. And to be honest, initially, it was the kind of atmosphere, watching everybody's excitement and stuff. And I think that what really sold it was going to Greenwich Observatory. And I attended this talk with these really 2 amazing guys who were very serious on this talk. And then I remember at the end, they just become like 2 young schoolboys as they got excited talking about space and the stars. And I was just like, wow, this is great. And it was... I don't know, it was just a lovely, I really just enjoyed, hanging around, that kind of thing. And then it just went on from there. I bought a telescope and, met some other people, eventually started a Facebook group. But yeah, still very amateur though, I have to confess, still very amateur. But I enjoy it, that's the main thing.
Oh, that's a really lovely story, how somebody invited you in and got you started. Last year when we were looking at Comet Neowise, there's a harbour near us and it's lovely and dark, so we were going down there. And the first night, my little grandson, he was 7 at the time, he saw it first before anybody else. We had a few quite professional astronomers with us, and he was the first one with his young eyes. He spotted it, but a whole lot of people were just coming down. They didn't know anything about it, and we were so excited. We kept saying, "Have a look through our binoculars," and then we remembered about COVID, that they shouldn't really be, but so many people got excited and absolutely stunned. They couldn't believe it. And then we started pointing out that there was a lot of planets on view at the time, and the Andromeda galaxy and whatever. And we got a whole lot of people just totally fascinated on the night. Now, I don't know if they kept it up, but I think that's sort of the way it goes. People just get fascinated then.
Definitely. It was quite interesting. And I think then on the back of that, actually in the summer, you're talking about Comet Neowise, there's a guy in my group and I met him. He was actually trying to get it on his camera, and I was walking past and I just noticed him with a telescope in his camera, and I just had to go up and say hello. It was just, and then he was saying he was getting Comet Neowise, and then he joined the group as well. So a lot of them on my little Facebook group are people in my community, and quite interestingly, I was mentioning to them about stellarium and stuff, and every now and again you see someone wandering around with a phone to the sky trying to map out what's going on up there. So it's great. It's we're all very, very amateur, but we have a lot of fun with it. So yeah, it's all good fun.
I love the way people get involved with each other.
Definitely.
People with the camera, and you end up chatting to them.
I know. It was like I had no choice. It's like a magnet pulling me in. It was like, hello. So yeah.
And we've got another nice comet coming at the end of the year, so there you go.
The $1 million question: will it be naked eye, do you think?
It should be. Yeah. It's looking like it's sort of like dusty at the moment. It's out towards the Jupiter sort of area, and it's looking quite dusty, so it's going to be quite good. It's going to make a very close pass to Venus on December the 18th or 16th, I think.
That's amazing.
Absolutely.
I remember when I was still in the States, I attended a lecture given at Harvard as part of their outreach program. And after the lecture, you could take a tour of the observatories there. And on the roof, they had four big Meade LX 200s, all pointed at different things. And one of them was actually showing the Galilean system. Looking at it for the first time, the atmosphere all depends on that. You're on top of a building as it is, so you've got hot air rising. So you've got this boiling air effect when you see Jupiter for the first time, and then you can see the four Galilean moons to each side if you time it right. When I remote into either the Canary Islands or into Chile to image, or even into New Mexico, the shortest exposure I've ever done, I think, was 5 minutes.
Wow.
And that was for a deep sky object. If I'm imaging the moon, it's literally seconds.
Yeah.
Normally, I'm just looking for a certain feature. Neil's seen my picture of Mont Hadley in Hadley Rill, which is close to an Apollo 15's landing site, and that part of their geologic investigations was Hadley Rill. Now, that took less than a minute to take the picture because the moon's so close and it's so bright. But then you've got to know what you're looking for. So I had to trace the Apennine Mountains on the moon right to where what I was looking for was Mount Hadley. And because I was enlarged the picture about 200%, there it was, standing there, beautiful. There was a little circular dot, bright dot, that was actually the peak of Mount Hadley. It didn't take long to find because I know the moon. I've spent so much time looking at it. I work round the mare. If I'm looking for an object, I just mare hop. With the dome, the Valentine Dome as it's called, that is on the Straits of Mare Serenitatis, the Sea of Serenity. So there's a little gap where the edge of the sea is, and it goes into the next one. So just slightly above that gap, there is a volcanic dome, but you have to have the illumination from the sun at a low angle to see it. If the sun's directly down, like it would be on full moon, you won't see it, which is why you can only really see the larger craters and the mare at full moon. So the best time really to go out to the moon is to follow the terminator, because as the shadows move across the moon, it will reveal some fascinating things. There's even an optical illusion called the Werner X.
Oh yeah.
Where there's actually an X drawn on the moon. There's actually a Y as well. There's two lunar X's and there's a lunar Y. Mm-hmm. And they're all optical effects created by the shadow of the terminator and the angle of the sun's light as it hits the edge of four craters in the case of the Werner X. So you can only really see the lunar X about just before first quarter. So now is a good time to get a map out, see where the crater called Werner is, and you'll see that there's two craters in the middle and there's a crater below it. And those are the craters that form the lunar X. As the sun's light crosses the top edges of the craters, you see an illuminated X on the moon.
I've seen it in pictures. It is actually it's stunningly beautiful, but it does need to be pointed out. I would never have known to look, only because I've seen it myself.
Yeah.
But it's not something you're going to spot just with a pair of binoculars. You need to know what you're looking at. Absolutely.
Yeah, as I say, you need to pick the right time of the lunaration, because basically it's just coming into first quarter when the light angle is such that it creates the lunar X.
Mm-hmm. Yeah.
How did you get into astronomy first, Susan?
Well, honestly, I think I was about 5, and it's always been a huge interest. I've kids. I've been bringing up kids for the last 30 years, and they're all getting older, and I've really gotten back into it again. So it's always just an interest that I read along with and look along with, and obviously then my brother is the same as myself. So and I'm really loving I mean, the lockdown has probably made it easier as well to be definitely just doing more and reading more and being on it more. And
Yeah, it's a really nice.
It's been up since I can remember. Sorry, Anne.
Yeah.
Sorry, Anne. Go ahead.
Yeah, it's just such a great hobby, if that's the right word. It becomes a passion.
Oh, it is a passion, yeah.
Yeah.
And it's a passion that never left me now. It just, other things take precedence over it. And I just seem to have a little bit more time these days. And, it's just, you know what? Any excuse, really. It's just fantastic. And
Even just to run out and look at the space station going over.
Oh, stop, I do. And I go out across the road from my house. There's a lovely little hill. And I go up and lie on the hill and just look up. And I know my neighbours think I'm a weirdo, but I don't care. And I have very, very low light here, so it's great. I see a lot.
Good. I keep meeting my neighbours. I go out sometimes just go out on the road and there she goes again.
Standing there looking up. Yeah.
Well, actually, you can hear the ISS as well as see it, because what it is, the astronauts all talk back to school kids using amateur radio.
Oh,
really?
Yes. So if you have a suitable receiver on 2 meters, you can actually hear the repeater on the ISS. There is a 2 meter VHF repeater in space. It beat a certain mobile company putting a 4G cell tower on the moon. So, in fact, the ironic thing is, at one point during a mission on the ISS, the station's main radios failed, and the mission commander, who was Russian at the time, used the amateur radio gear to literally talk to Moscow by doing what they call a phone patch.
Right.
So as the station went overhead, radio amateurs were actually contacting Russian mission control, and they were basically handing him on to the next operator so he could discuss the issues they were having with the ISS.
It's amazing, like.
Yeah, and of course the astronauts can speak to school children through amateur radio and through slow scan television. And these events there are notices on the websites that tells you when they're going to be talking to which school, so you can actually listen to the conversation between the school kids and the astronauts on board. In fact, the space shuttle had amateur radio in the form of a 2 meter transceiver built in. Kennedy Space Center has its own 2 meter repeater, and I always used to know when there was about to be a launch because I would log into the repeater to listen, and this message comes across: the Kennedy Space Center 2 meter repeater is currently locked down, and is not available for use. There would be a brief announcement every time just before they launch the space shuttle. They're using a handheld walkie-talkie to talk to the Earth from the ISS.
It's quite amazing.
Yeah. I am being offered cake.
Nick, don't take the cake. Talk the moon. Don't take the cake.
But I want the cake. I want my cake and to eat it.
No, the moon. Okay, fair enough.
My daughter is sitting there eating her cake in front of me, and she's face palming.
Oh, well then, I guess that's it. Cake or the moon, and you take cake.
One thing I will say about astronomers in this current day and age, we've been championing social distancing for over 600 years. Well, I'm being questioned on that one. Well, if you think about it, most astronomers in the past used to be solitary people on top of mountains with not having much to do with anybody else.
Billy no mates.
Oh dear.
I'll be soppy and say you're never alone when you look up at the sky.
True.
Very true. And we're all looking at the same moon.
We're all looking up, you know.
If we don't cut now and we use the word country, that could go badly wrong.
Okay, so I think probably on this note, the best thing is to say it's good night from me, or is it good night from him?
Yeah.
Thank you very much, everybody.
It's been great having everybody on. We'll have to have you back again soon.
Let's have a wild picnic, socially distancing, of course, in Hyde Park.
This is the most company I've had in I don't know how long. So thank you very much.
Enjoyed the chat.
Thank you for inviting me on. It's been really lovely to meet you all, and so thank you.
Great to have you on board.
Thank you for coming.
Bye, everybody.
Good night, everyone. And look up.
Goodbye.
All the best now.
Bye.